So remind me here what the displacement means. What does it mean that we want to find our total displacement?
How far away from?
Good, exactly. Distance from the starting point. How far we ended up from where we started. Okay, that's what we mean when we say displacement. So how many vectors do we have here that we're looking at? 4 vectors. We have 4 total vectors. Okay? So there's a couple different ways you can go about solving this. Do any of these vectors work at an angle? Any of these 4 vectors, do we have to break any of them down individually? No, because they're all going a simple cardinal direction. Okay? So for vector 1, we've got them going 1 kilometer north. Vector 2, 5 kilometers west. Vectors 3 is 3 kilometers south. And then 7 kilometers east. Okay? Our overall goal here is to find out how far we ended up from where we started. So if we add these vectors tail to tip, it's going to give us a kind of a crazy path to our final point. Okay? Does it matter in any way what order we add these vectors in? No. Either way, it's going to get us to our exact same finishing point. Okay? But let's go ahead and start looking at our vectors here. The way we're going to break this down is we're going to add total x and total y. Then we build our new triangle. We find our hypotenuse. We use second tangent to find our angle. Is that ringing a bell? Add all x and add all y. Okay? So I could break each of these vectors down into v1x and v1y. Okay? This is taking a little extra step because we know all these are cardinal directions, so we don't really have to break them down. But it's okay to get the whole process down. So if I wanted to look at v sub 2x, what would my v sub 2x value be? -5, good. And why is it negative? It's going west, very good. And I have no y component there. Okay, so v sub 3x is going to be 0. And v sub 3y is -3, good. V sub 4x is 7, and v sub 4y is 0. Okay, do we see where all those components came from? Again, breaking those into x and y is kind of an extra step. You don't have to do that, especially because they each work with only cardinal directions, so we're not really having to break those down, but we can to make it a little simpler. Okay, now we're going to add all of our x's and all of our y's. So we're going to take -5 plus 7. V sub y is going to be 1 plus -3, which gives us 2 and -2. Okay? So that tells us those are the components of our new resultant vector, our displacement vector. So now we're going to add these vectors tail to tip. We're going to pick an origin, and we can go in the y direction first or in the x direction first. Aren't they both going to get you to the same place no matter how you add them? Yes. Okay? So my x direction is going to go which way? To east or west? East, because it's a positive component. And my y component is going to go north or south? South. So I'm going to add that tail to tip. That part is really important. Okay? When we have our components, we have to add those tail to tip. Otherwise, we don't end up anywhere from our origin. Okay? So here is our resultant vector. And what angle are we looking to find here? This angle or this angle? This one right here, the one that touches the origin. Okay, that's going to be the one we're looking for. Okay, and how do I go about solving for the question mark here? Pythagorean theorem. I want to use Pythagorean theorem to find the hypotenuse of that triangle. Okay, Pythagorean theorem. All right, what did we have for our hypotenuse value? Good, 2.83, and our units are? Kilometers, good. At, what's our angle? Good, 45 degrees. Could we have determined that without even having to plug in second tangent? Yeah, because both of our sides are the same value, so we know that's going to be a 45-degree angle. In this case, what's at 45 degrees blank of blank? Where is it? North of west, east of south. What do we think? South of east. Good. It's touching the east. And we're going south from there, so it is south of east. Very, very good. Okay, number 2, I want you to try that one on your own, and I want you to pay attention to the fact that on it says he goes in a northeasterly direction for 4 miles. That when it says northeast and it doesn't give you an angle, it means exactly 45 degrees. Okay, so northeast, it's going 45 degrees. You can pick either side of that. Okay, so I want you to go ahead and try this last one on your own. I'm sorry, this number 2. Okay, are these the components that we had? Do they match pretty close at least? V sub x and v sub y. So what direction should my x component be going in my resultant? West. Good. Okay, so as I start putting this problem together, I want to go west and then north, because my v sub y is positive. So 5.82, 2.18. Find my hypotenuse and find 6 point what? Units. Miles. Good. At. What's our angle here? Okay, and if we found this particular angle, what are we? North of west, west of north, where are we? North of west. Okay, so another acceptable answer would have been, what, 21 degrees, 21.6 west of north? 21.6, yeah? Did anyone solve it that way? No? Okay. Doesn't really matter. At an angle of 20 degrees with respect to the horizontal, determine the horizontal and vertical components of its velocity. Okay, this is an introduction to the type of problems and the type of vectors we're going to have to start breaking down for projectiles. Okay, so this is an example of that. What it's telling us here is that we're moving 200 meters per second. That's a velocity vector. And we're moving at an angle 20 degrees from the horizontal. So from the horizontal means we start with our regular axes. Okay, and we assume the horizontal positive axis looks like that. Okay. So our 20 degrees is going to fit right in that little pocket right there from the horizontal. Okay, so you're going to start at the horizontal and you're going to move in the positive direction. Okay, and where would my 200 meters per second fit in this particular diagram? Yeah, it's the hypotenuse. Good, it's our vector. 200 meters per second. Okay, so that means these sides right here are going to be my components. Okay, so I might call this v sub y and v sub x. Okay, those are velocity vectors. So what should the units for these two components be? Meters per second. Good. Anytime we break down a vector, our components are going to have the same units that our hypotenuse does. Okay? So let's go ahead and break this down. If we want to solve for v sub x, we take our hypotenuse times sine or cosine? Cosine, because it's adjacent to that 20-degree angle. Let's make sure that all your calculators are in degrees, not radians. Okay. And I got about 187.9 here. Yeah? Okay. Meters per second. And then v sub y, we take our hypotenuse times sine of 20 degrees. And I get about 68.4 meters per second. Okay? And if I want to put a cardinal direction with these components, my cardinal direction for y would be what? North. And my cardinal direction for my horizontal component would be what? East. Okay? Because it's moving in the positive horizontal direction. So what I want you to think about here is, although this airplane is actually moving 200 meters per second, if we looked individually at its speed in the horizontal direction and its speed in the vertical direction, it would be traveling 187.9 meters per second only east, and it would be traveling 68.4 meters per second purely north. Okay, so if we broke these down into its components, its horizontal and its vertical components, it would be traveling at those two speeds respectively. Okay? And that's really important. That's going to be something that we use a lot in this next projectile chapter. Okay? Any questions here on breaking down that vector? Once we break down our vectors, remember that we're done with those values. Okay? Once we've broken down a vector into its respective components, we wouldn't use the 200 anywhere else in the problem. We wouldn't use the 20 degrees again in the problem. Okay? Once we break down the vectors, then we're concerned with these two values. All right? Okay, so we're going to skip that number 4 for right now and move on to number 5. All right, this tells us a plane flies 452 kilometers per hour at 52 degrees west of south. What are the components of our velocity vector? In this particular case, we don't have to convert it to meters per second. We can leave it in kilometers per hour, that's fine. Especially if you look at the next two parts of the problem, it asks us how far we've traveled after a certain number of hours. That means we want our velocity and our time units to match. Okay? So we can go ahead and leave that in kilometers per hour. So I want you to go ahead and try to draw this vector first and see if you can match mine. Okay, go ahead and try to draw that vector out, 52 degrees west of south. Draw the components. So our vector should look something like this, where we're going to draw it in the southwest direction, 452. Then we're going to decide, does it need to touch the west axis or does it need to touch the south axis? It needs to touch the south axis. Okay. So that means our vector should look like that. If I'm going to label my sides, what would I call this side right here? Yeah. V sub y, and bottom would be v sub x. Okay, so let's go ahead and break down and find those components if you haven't already. V sub x, we take our hypotenuse times sine or cosine. Sine. Yep, sine this time, because it is opposite of that 52-degree angle. So we have to be careful we don't give ourselves a rule that x is always sine or cosine, whatever. Okay, we have to be careful and look at that. All right, and for these two values, what do we get for v sub x? Jared, tell me what you got. 356.18. Okay, I'm at around to 0.2. Good. And what direction is that going? For x? West. Good. So we can either put a negative there, since it's a component, or we can label it west. Okay, either way. But we've got to have one or the other when we're looking at those components. Okay, you have to have one or the other, either the negative or the west. Okay? Katie, tell me what you got for v sub y.
278.3.
Good. South. Okay, so we're going to label it south, or we're going to give it a negative. Either way. Okay, but not both. Okay, I'm just showing you both. Okay, any questions on those components? Feeling good? Okay, I want to take it a little step further, and we're going to see how far the planes traveled directly west after that time and directly south. So to do that, we're going to use the components that we just solved for. Okay, These have units of kilometers per hour, which makes them what type of a vector? A velocity vector, a displacement vector, an acceleration. What type of a vector? They're a velocity vector. Okay, so 356.2 or negative 356.2 kilometers per hour, that's our velocity. Okay? Here we're given a time of 1.34 hours. Okay? So if we want to find the total distance it's traveled, we're going to take our very, very first velocity equation, v equals d over t. Velocity equals distance over time. And we're going to be able to solve for the distance that's been traveled. Okay? This equation right here only works if something's moving at a constant velocity. It doesn't work if something's speeding up or slowing down. It doesn't work if it's accelerating. It only works if it's moving at constant velocity. So we can go ahead and set this up to say negative 356.2 equals distance over 1.34 hours. Okay, this is our velocity in the west direction, and this is our time that we're traveling at that speed. So to find d, or to solve for distance, what do we do with these two numbers? Multiply them. We multiply. Okay, and if our displacement vector comes out negative, what's that tell us? Yeah, it's going west. Good. And I got about, let's see, Isaac, what'd you get? 477.3 kilometers west. Okay, there's our final answer. So if we go south, that means we're going to say negative 278.3 equals distance over 1.34, and we get a value of 372.9 kilometers south. Go ahead and do number 6 and 7 on your own. We're just breaking those down and finding the components of each of those, so that'll be pretty quick and easy.